Hello, everyone. This is Michael Kennedy. Thank you for coming to the Wintellect webcast. I'm super excited to share some Python experience and ideas with you today. Now, you're all in listen-only mode, but I would love for you to put messages into the chat. If you have questions, put them in to the Q&A. Maybe somebody just put something into chat real quick to make sure you're all hearing me okay. Oh yeah, wonderful. Okay, so thanks for coming. We're going to be talking about Python, but before I get into that details of that, let's just talk real quickly about Wintellect. So you've all registered here. You're probably familiar with Wintellect. They do software development consulting, they do training, and they have online learning via their Wintellect Now platform. So whether you want in-person training, online training, or some of the best software developers that I know to come and work with you, especially in the .NET space, give those guys a call. So who am I? Well, some of you may know me. My name is Michael Kennedy. I run the Talk Python to Me podcast, and here I've interviewed over 100 experts in this field, and I hope to take some of the ideas that I've gotten from talking to all those guys and girls and bring that to you here. So here's a picture of me, in case you haven't seen what I look like yet. So we're going to talk about Python today. And the assumption I'm making for the audience, it'll still be relevant if this is not true for you, but the assumption that I'm making and the way we kind of set the title and stuff up here is this will be for .NET developers who are somewhat experienced in .NET. You know things like Entity Framework, you know things like LINQ and Lambda expressions, and ASP.NET, those types of things, and you're considering using Python. So the idea is we're going to look at the parallels of those concepts in Python, and you'll see almost every major language or platform feature that you really know and love from C#. There's a analogous feature in Python. And sometimes the feature in Python is actually even better. So we're going to go through that. But before we do, let's just take a moment and look at the ecosystem just a little bit, because you may not be entirely familiar with it. We're going to be using Python 3.6.1 here. There's basically two versions of Python, but the place you should be these days is Python 3. I'm happy to answer questions later about why I would say that, but that's certainly the most modern one, has a bunch of the great features we're going to talk about. One of my favorite places, one of my favorite things that comes out in here is Stack Overflow. Their survey, they interviewed like 64,000 developers, and recently, this is like a month ago, they released their Stack Overflow survey. And if you come down here and you look, what are the most popular languages? These are languages people are using. You can see C#, where most of you probably live, is quite popular, but there's somebody knocking on the door right here. All right, right behind it. Now this is interesting because this is the number of questions on Stack Overflow, basically by tag, right? So this is interesting. Another way to look at popularity is GitHub. So GitHub has a ton of different projects on it. However, if you restrict the ones that you consider to the ones that are active, the ones that have been used recently within the last year and have like a non-trivial amount of code in them, you'll see that Python is actually the second most popular language on GitHub, far above C#. Okay, so Python is quite a popular language. Also, if we come down, one more thing I want to show you from this survey. Well, let's look at two things. Let's look at this full screen here. If you look at the trends of the languages that we know and love, JavaScript is kind of going up. It's had some bumps and whatnot. Node.js, pretty solid. Java going down a little bit. C# is not telling a great story here. It's on a downward trend, honestly. So that's not amazing. But Python, upward. So that's really good. The final thing, there's a reason for that. If you look at the most wanted section, there's one language that is wanted more than any other, even more than JavaScript. So this is a language that definitely has a lot of job prospects. It's growing fast. There's more demand than there is supply for Python developers. These are all good things for you. Let's look at the ecosystem a little bit more. So one of the things that .NET developers love is NuGet, right? You go and install Entity Framework or JSON.NET or whatever package it is you want to install, right? The HTTP client from Microsoft.NET.HTTP, right? Something like that. And it's really cool. There's 77,000 packages here. That's pretty awesome. That's a lot of libraries you can grab and use. In the Python space, we have the same thing. It's called PyPI, Python Package Index. If we pull that one up, it also has a couple of things. In fact, it has 106,000 projects. All right, so like a third more, maybe, something like that. And I don't know the numbers for NuGet, but the traffic on the infrastructure that powers PyPI is basically 400 terabytes a month of transfers. One of the most popular packages on there gets downloaded over more than 7 million times a month. So people definitely use the same concept as we have in NuGet. We use that in Python, and it's been there longer, and I think we use it probably even more, actually. Okay, so I'm going to start with a quick language introduction. We're going to build a little game. If you came to my webcast a few weeks ago, this is a different game. We're not going to build the same game because that would be boring. So I came up with something new for you. And then we're going to look at a few language features, and we're going to focus primarily on like a full stack web app in Python and make the comparisons to like, okay, well, where's the ASP.NET part look? Where do we find that? What does it look like? What is the Entity Framework story? Things like this. Let me just check questions really quick before we move on. See, there's a bunch of hello. That's great. Loud and clear. Okay, very cool. So it looks like everything's going. If anyone has questions, just throw them in there. All right, so let's switch over to code. And for pretty much the rest of this time, I'm going to just be writing code for you. One of the questions I frequently get asked is, will this webcast be available later? Yes, it will. It'll be available in download form, and the code that I'm writing will be available at github.com/Wintellect. So I'll pull that up at the end here, but right here we're going to work in this area. So let's start with a, I'm going to create like a Dungeon and Dragon game. Call it game, so like just so it looks a little bit different. Now we could use all sorts of editors, and a lot of people use really like terminal-friendly editors in Python, like Vim, Emacs, those sorts of things. Sublime Text is pretty popular. But if you're coming from .NET, this whole super lightweight, get out of your way but don't help you very much editor, not so amazing. You want something more like Visual Studio. And one of the best extensions to Visual Studio, in my opinion, is ReSharper, right? ReSharper is awesome. I've used it for years when I was doing C# stuff. And if basically the JetBrains guys went and built their own IDE, like their own Visual Studio, which they actually are doing with the writer now, but if they went and built that, it would look very much like PyCharm, right? That's actually what they built. So PyCharm is a full Python IDE from JetBrains. Let's go ahead, and you can see it manages versions, version control, Git, all that kind of stuff. So we're going to use this to write our code. Now, this is just an empty folder I dropped on here. You can't do that trick in Windows or Linux. You've got to say File, Open Folder, but in Mac you can. So what I'm going to do is I'm going to start by creating a little program here. We're going to look at just the structure of Python a little bit. Let's make it fun. Call it game. Okay, so in our game, what we want to do is we want to do a few things. We want to tell the user, welcome to the game, and we need to set up the game, and then we need to play the game. Okay, and the game that we're going to play, it's going to be kind of like a Dungeons and Dragons MUD. I don't know if you guys are familiar with this from back in the day, but it's like a text-based adventure type game, right? Now, keep in mind, this is like a 10-minute demo. So we won't be able to like create, full-on MUDs totally from scratch. But let's go ahead and get started here. We can start by just making this thing able to be run. See, there's a little play button up here, but it's gray. So the way we get that to work is we right-click, we say Run Game, and then, we don't have what's called an interpreter, so let's go set that. Basically, it's saying, what version of the project, what version of the runtime do you want to run? Why is there none at all? That is not really acceptable. Okay, let's go with Python 3. Will that work? That is quite bizarre. Let me, there's something that was weird about this thing earlier. Just a sec. There we go. Like why that list was empty, I don't know, but it doesn't really matter. Okay, so we're going to tell it we want to run with that version 3.6 of Python. And there it goes. Okay, so let's start out with just some simple things. One of the things we want to do is we want to print out a header. I'm going to write this kind of the wrong way, then we'll make it nicer. So we could print this out. We could say, let's put a little star. And I could do this. I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could count, maybe we want 80 because we have 80 columns. But in Python, you can multiply characters and numbers and strings. That'll make a string of length 80. And then I want to print out something like a header or a logo or something. But first, maybe I'll say, welcome to the dungeon where dragons come to play, something like that. Right. Now if we run this, you can see it's printing out this little thing like you would expect down at the bottom. Now I want to put something a little more interesting in here. I want to put like a cool little picture. Like this doesn't feel like much of a game. So I have a few files here. Let me pull them in. And we're going to use these for different parts of our game. So I'm going to put 3 files over here. Okay. Oh, go away. Okay. So we're going to pull in this logo one. So we'll say logo equals. Now I want to open this up. In .NET, we have using blocks, right? If I was going to open a file handle, I would want to put it in a using block. So if there's an exception or I return early, I won't forget to close it. In Python, we have exactly the same thing. It's called a with block. Technically, it's called a context manager. The syntax keyword is with. So we'll say with, open this file. We'll say logo, get out of my way, .txt as fin for input. Now, we come to the first case where something is a little weird, different and quite unusual coming from a C-based language. We don't define our blocks like this. In Python, we have a lot less syntax, and we use the structure, the shape of the file itself to actually tell you what the blocks and the control flow and everything is. So if I want to run code in this little with block, I don't use curly braces. The way you do it is you say colon, I'm about to define a block, and watch when I hit enter, there's an indent. So I could come down here, I could say text equals. The fact that there's 4 spaces right there means this is part of the block. And down here, I'm now out of the block. This is the most different thing coming to this language, I would say. And it takes a while to get used to, but once you get into it, it actually is totally fine. Like for example, when I hit backspace here, PyCharm is deleting all 4 spaces because it knows what that means. When I hit enter, it goes in 4 spaces. I hit tab, it looks like it tabbed over, but it's really 4 spaces, okay? The editors make this totally fine. So let's just read this in. And let's print this out. Let's just print the text, okay? Okay, so let's run this again and see what we got here. You might have noticed what that little file was. We've got a cool little dragon, okay? So our dragon is here. That's just what that was in that text file. We've got a little intro. So we got to do a few other things. But how do you guys feel about this? You guys loving the fact that this is just like a little bit just dropped in. There's no functions, nothing like that. So we're going to put this into a function. So in Python, you define functions like with the def keyword. So you say def, and this we can call this print header or something like that. Okay. And again, we use this colon and indentation to say that stuff is in the function, other stuff down here is not. Of course, if I run it, nothing happens because we've defined the function, but we haven't called it. So let's define a main method. Now, in C# you have a main, and the main method means run this thing, right? Like the C# compiler finds static void main and runs it. That doesn't happen here. So we have to sort of do that ourselves. So we'll say main, and then we'll just call print header like this. If I run it, you see nothing happens. You have to call it at the end. And then there's this idiomatic thing that we do in Python There's basically a way to indicate, is this being used as a library or is this being used as a program? And it looks a little weird, but the way it looks is you say if there's this implicit thing called under name, if it's main, that means we want to run it. Otherwise, we're just trying to import the functions, okay? All right, so now you can see our little dragon is back. But let's do some more things. Let's say build room. Rooms like that. We'll say room here. Now notice this function doesn't exist. If I hit Alt-Enter, now it exists, all right? And let's come down here and say play a room, and also make that exist. Oh, whoops, I may have imported something instead of creating a function. Okay, now let's move these characters below, have our main up at the top. Okay, so how do we build a room? Well, I think this is enough pure functions. Let's have some classes, all right? So just like in C#, we can have classes. So we'll come down here and I'll call this a room. Actually, I wanted to call it lowercase room, but I'll fix that in a sec. So we can come down here and create a class, just like you do in C#, say class room, but instead of curly braces, as consistent with Python, we do this. Now, the next thing we need to do is we need to add some attributes and a constructor to basically pull in the data from wherever, right? We're going to construct different types of rooms and whatnot. So let's do that. I'll do that for this one real quick, and then I might do a little copy and paste for some other pieces so we can move on to some, the ASP.NET equivalent. All right, so we're going to define what's called an initializer, and all of the sort of system level, language level, operator type functions have double underscores on both ends. And you typically call that dunder something, so dunder init. So this is the initializer here, and we're going to pass in some values. I want to pass in the name of the room and the creature, like a room can contain a creature which we could fight, the contents of a room, maybe it'll be like a sword, who knows, and then we'll have three things. It could go left, right, or forward. So these would be like the rooms that you could move into from this room. Now notice PyCharm saying this is not used, we want to do something with it. So I can hit Alt-Enter and start adding these to this class. Now, because Python is dynamic, the way that you add them, oops, I don't want to add that much, I want to do this, is you say self dot, and you basically define dynamically this type, the fields of this type. Now the convention is this is only supposed to happen in, inside of this particular initializer. You're not supposed to be able to do that. So if I like another function like def other, and I said self.thing equals 7, you can see PyCharm saying, no, this is actually only supposed to happen inside this initializer, okay? So there's a couple variations on this, but let's just leave it like here for now, okay? The other thing we can do is we can give these defaults. So let's say if you don't give it a name, it'll be called a room. Here we're going to set the creature to no creature. In PyCharm, null is none. So here we're going to say the contents is also empty, and I'm just going to copy because the rest are all the same. By default, there's no left, right, or forward rooms, but of course you could set them, and then there would be. All right, so this is how we create classes in Python. And if I want to use it down here, let's say in the room, I'm going to build a room. I'm going to allocate a new instance. You don't say new, you just allocate it like this. Then I could return that room. We'll do more with it in a moment. Okay, we're going to give that back. Notice it doesn't implicitly pull this room in here. We have to go to the top, and like you say using, we say import. We could do it in a couple ways. We could import room, and then if we say that, we have to come down here and say room.room, and so on. But let's say it in a different way. Let's go up here and say from this, we'll import room. Okay, now it knows what this is down here. All right, so let me copy and paste a little tiny bit here, just so we're moving along. So I'm going to need to have a creature, or this is going to be a very boring game, right? Whoops. Let me copy a slightly smaller powder code. So in our room, we're going to have this creature called a dragon. Geez. Sorry. My microphone like covers my keyboard, so it's hard to see what I'm typing. So we need to define another thing called a creature. So let's have another class called creature. And this one I'm just going to copy over because it's really not worth watching me type all this stuff out. You're kind of getting the idea. So we'll just review our little creature here. So our creature, again, has an initializer, has a power and a name. And we're going to randomly, when it fights, randomly get sort of a throw or whatever. This is like 0 to 1, a floating point, and then we'll multiply by your power, and that will be the thing that determines whether or not you win or they win. So to use this from the standard library, we're going to import that as well. And let's go back here. So we got to import this like that. So we have our little creature. So now we've built a creature and we've built a cave, and in that cave we've added, we've given it a name, and we've given it the creature. And then we created our starting area. Let's go here, and I could call this the main hall or whatever. Right? I could use the positional parameters, or I could name them just like C#. They have default values as you saw. So we're going to create a main hall. We're going to give it a cave. In the cave, we're going to have a dragon. That's the thing that we're going to fight. Okay. So we're getting close. We're printing the header. We've built our room, and now we need to go and play. And play does not do very much yet. So let's come down here, and I'll put a real simple version in place first, and then I'll put a slightly better, more fun one in a moment. So let's come down here, and we need to have you as a player. Right, so we're going to create this player, and this is just going to be another creature, and then you get to decide, like, I'm a level 15 wizard or whatever you are, right? And this is the thing that's going to battle the stuff that happens to be in the room, like the dragon in the cave. So now we're going to come down here and say, while true, not white, while true, we want to do some stuff. And primarily, this is going to look like, hey, what do you want to do? You can go do this. You can go do that. And so let me copy a little thing here just real quick. So we're going to use this function called input. Now let's wrap this around so you guys can see. And this basically is like console write line plus console read line for you guys. So it's going to issue a message to the user and say, what do you want to do? Do you want to look? Do you want to fight? Do you want to move left? And we can make this a little more obvious, etc. Like this. And then we're going to strip off the white space and lowercase it so there's no nothing to worry about. So let's do this. We need to have the room that we're playing in. Yeah, that's fine. We already have that. And then we're going to say if. So we're going to do another if statement here. Or we haven't done an if statement, have we? We're going to do another block. We're going to do if statement. We'll say if action, very much like C#, double equals, is right, then we want to move into that right room. So we'll say something like room equals, I guess I need to check, and room.right. So make sure that we have a room to move into. So it's going to be that, and we'll print you have entered this. Okay, so when we get to a print statement, this is like console read line. We're going to do curly braces here, just like you do in Python, C#. Normally you have to put numbers in C#, 2, 5, whatever, and in Python you can just leave it blank like this, and it'll just take the positional parameters. Okay, you can also do the format strings. I could do room.name here, just like you do in C#, the new one, but I'm going to take that off because this is a C# 3.6 feature, and not everybody has C# 3.6, so we're going to leave it like this. Now, one of the questions I get often is, people, not in general, but people coming from static languages like C# is like, doesn't it make you crazy that you are defining these things with no type? Like I say dragon here, and I don't say creature dragon or something like that. I just say dragon. It takes some getting used to because it's different, but it's not as big of a deal as you think. Like what is super painful if this was JavaScript and you say like var and then you say dragon dot, like it doesn't usually know what is available, right? Well, check this out. If I'm down here in play room and I say a room dot, notice left, right, forward, creature, name, contents, etc. How does it know? It's because PyCharm is traversing the abstract syntax tree and very carefully understanding, okay, well, in main, you called build room. So if I look at build room, you created a starting that was of type room, you return that, you passed it here, and it just knows, it traverses the whole abstract syntax tree. Basically, as much as type inference as possible in some other languages, it does that at edit time, okay? So that's pretty neat. I see a couple of questions. Let me see if I can answer them really quick. A couple of questions. Stefan says, aren't old style classes deprecated? Yes. Yes, old style classes are deprecated in Python 2. In Python 3, this statement is tantamount to this. These are identical statements. There is no old style. There's only new style. So whether you write this or you write that, you get the same thing, okay? So yeah, they're deprecated, but in Python 3, it's not a problem. Yeah, somebody says, am I using fight for forward and fight? Yes, apparently I am using that for both. We'll have to come up with something else. But it doesn't matter because you can never go forward. Yeah. Someone asked, does the sequence of the functions here matter? And yeah, they matter a lot. So notice over here, I've got main defined first, and then play header, and then build rooms, and so on. Now, there's no compiling, right? This just runs. Like execution of this line here, the result of that execution is the definition of the function main. But it doesn't try to evaluate what is inside until you actually execute it. So you can put main first and print header next as long as this execution of it is at the very end. Like long as play and build rooms and stuff is defined by line 39, you're good. So it matters, but not as much as it might seem it matters. Would I consider using VS Code? Yes, I would definitely consider using VS Code. It's not as good as PyCharm, but it's one of the better editors, and there's a very good Python plugin for it. It's the most popular or second most popular extension, so definitely use that. Now let's see, what happens to type inference if you call the function with a parameter of different types? If you call the function with different types, it's interesting, like let's see down here. If I go to play, let me try to play again here and wait for a second. Notice this. It says room, colon, and it has in parentheses, it says, this is the implicit interface that this thing must have. So room, it doesn't have to be a room. It just has to be an object that has a right, and the right has to have the property name, which it doesn't really indicate here because that would get insane. But basically it's saying there's this implicit interface of you give me a thing that has a right and we're good to go. So that's more or less what happens to it. It has to be that they both have this type. Okay, so let's move on really quick here. Let's do one other thing. Let's look around, and I'm going to copy and paste something real quick because this is like kind of intense here. So we'll say this. We'll say if it's a look action and fight, let's put W for forward. So come down here, we'll say action is left, look, sorry. And if there's a creature, it'll say there's a creature here. If there's nothing, if there's a room on the left, it'll say there's one on the left, if it's one on the right, and so on. Otherwise, there's nothing to see. So let's go and let's actually run this outside of PyCharm, which is, it's fine, but it's just like too small. So let's go over here and say cd that. Let's say Python game, Python 3 game. That's not helping. All right, so we run it. It says, welcome to the dungeon. Here's our cool little logo dragon thing. And we can look around. And there's a dark cave to the right. And do I have the ability to move to the right? I do. Okay, so if I hit R, we've now entered a dark cave. Look again. Oh, there's a dragon here. I could fight the dragon, but we haven't implemented fight. For the sake of time, let me go ahead and just put the rest of this game loop in place. Okay. But I wanted to do enough of it that you guys get a sense of like what the language itself looks like, okay? What it feels like to write code here. Because if I paste it like this and I tell you, oh, there's these indentations and these colons that mean that's the space, you're like, oh my gosh, that looks really crazy. But if you see that like I did nothing special other than type :enter to make these appear, right? The whole editor took care of all of this for me. So let's see if that works. So I'll just walk you through it. Same thing here for the left. That didn't change. When we fight, now we check and see if there is a creature. And if there is, we fight the creature. We call u.fight, whatever the creature's name is, and either you win or you lose. And let's do real quick here. Let's do open with block with open. What is winning? No, losing. Losing.txt as fin, and we'll print fin.read. Notice there's read lines, all sorts of stuff. Read character, etc. We're gonna do this. And down here. And let's go ahead and break out of the game when you win as well. And when you die, let's do, whoa. I had this one. This is winning. Okay, cool. So let's see if my copy and paste carried over okay. So we'll try it again. Notice our 80 character string matched perfectly to our standard 80 character output. All right, so let's look. Oh, there's a dark cave to the right. Very well. Let's move to the right. We've moved into the dark room. And now we can look around. There's a green dragon. And now, excitingly, we can fight the dragon. Let's do it. Oh, we've been defeated by the dragon. I should probably say you rolled this, they rolled that, whatever. Let's try to play one till we win, right? We don't want to go out on a losing note here. So let's move right. Let's fight the dragon. Yes, we have defeated the dragon. All right, so this, you've learned like a significant amount of the Python language right here. Notice there's no parentheses here. This will still run. Like this code is fine here. However, these are just unnecessary. And look, PyCharm is going, you can remove these redundant parentheses. There are times when it makes sense for like multi-line statements and whatnot, but most of the time you don't have to type them. There's no parentheses here. There's none here. There's no curly braces. There's a lot of stuff that's absent, and it feels a little bit unusual when you get started, but after a while, if you go back to a language like C#, you're like, whoa, why am I typing all these symbols? They are really not needed, are they? Because I did something else somewhere else and they actually weren't needed. So it's really nice, but it definitely takes some getting used to. But you've learned a lot about classes, right? Classes over here, right? We've created these classes, we've got their initializer, their fields, defining functions on them. Notice you also don't have a return value. I don't say like this, bool, something like that. Don't say that. And the reason is every function has an implicit return value of none or the thing it returns. And there's no types you have to say, so you don't have to worry about it. Now you can add typing in Python 3. You can say this is a creature and it returns a bool like so. Yeah. I'm not sure why this is a little freaked out, but basically you can say this is you could annotate the types. Like I could come over here and say this is a string, this is an int, and now if I say power dot, you can see I get int type things. And if I say name dot, I get string like things. Okay, so you can annotate them, but these are not runtime statements. These are just hints to the editor, let's say. All right, so done with this thing. If you guys have questions, let me look real quickly and see what you got there before we move on. Yeah, why do I have a left and a look? I guess because I never tried to go left. You're right, Shane, so I should probably just change that. Have I deployed to Azure using the Sci, probably is autocomplete SciPy. It says SciPy libraries. No, I haven't. I wrote all my stuff on DigitalOcean and on Linux, and that's like a fifth the price. So, but no, I haven't. Is there some kind of Py launcher on Mac or Windows that interprets the shebang? Yes, I could put a shebang here. I didn't. I typed Python 3. But if I did two things, I'd have to say change mod a plus x this to make it executable, which is always a pain. But now you can see its colors changed, so it's executable. And then I could put a shebang. I don't even remember the shebang. I think it's /user/env python3. Oops. Now, go away, little helper. Now, if I say game.py /game py, is it user bin? I don't know. Can't find. Yeah, I don't know. I got to figure out. I'm sure I have that wrong. You guys can tell me if you know off the top of your head. Oh, you're right. I did that in the creature. That's not going to help because that is not what I'm executing. Okay. Yeah, so now I got to change mod. Yes, right? Why is that not running? One more try, but it doesn't matter. Yes, it will interpret it. It will interpret it. Yeah, whatever. I had it right before, but in Windows, there's a py.exe, and the py.exe will understand this statement here, even though it makes no sense on Windows. It'll go, oh, you mean Python 3, and it will run on Python 3. If you put a 2 here, it'll run on Python 2. Yeah? Okay. How does Python compare to JavaScript? I would say Python is a much more well-structured language in terms of it wasn't built in 9 days. It was built slowly over 10 years. So in that sense, it's different. It's also super different in its performance story. So Python has many extension capabilities. So you can have like C extensions, right? So what I'm about to show you, some of the pieces actually run straight C code where it would otherwise be slow, right? So the performance of this can be much better, right? Like it depends, of course, always depends, but it can be much better because like we were talking about before, the SciPy and NumPy pieces, right? That's basically executing straight C, and for all the benefits and drawbacks of that, but certainly performance and extensibility is a big one. Okay, so let's put this away and let's go build something else, all right? Hopefully that was fun, except for the part where my little interpreter didn't run. That wasn't fun. And let's go over here and make a new thing. Let's focus on some web stuff first. Okay, so let's go over here. Now I want to go and create a new website. Let's cd into this directory. Pop. All right. So I want to make a new website. Now I could go and install the web framework and create a simple shell of a program, like a really basic starter program. But I want to do something more fun than that. I want to start from something farther down the line. So there's this thing called Cookie Cutter, which I'm going to use. So Cookie Cutter takes project templates, and let me just pull that up real quick, and it'll turn them into some projects. So if I look at Cookie Cutter and just look around here, actually this is the one I wanted, and go somewhere to where it's pantries. There it is. This will show you all the things you can create. So it's a Python program, and it primarily makes Python things. We're going to use this pyramid framework and this piece right here. I'm going to use that thing. Okay, but it also will do get stuff. It'll do C, C++, C#. There's even somewhere in here where it'll make like Atari games. This one, yeah, I think so, an Atari 2600 project. Okay, and a assembler. So it'll make anything. So what I want to do is I want to use that tool against this, which comes from something that I've done elsewhere, and it creates a very rich web app already with the data access integrated, with other things integrated, and so on. So let's run that here. Whoops, I got to put Cookie Cutter in front of it. Okay, so we're going to run this, and it says I've already done this one. So do I want to get a new copy? Yes. And so it asks, what's your project going to be? I'll call it a Wintellect demo. That's what it's going to be. And notice it's picked like a package name, an assembly equivalent of assembly name for us. It says, what is your company name? I'll put mine, Talk Python. and my domain is talkpython.fm. So it says maybe contact@talkpython.fm works. Yeah, sure, it's fine. This would be going to meta tags, and then it says, hey, there's a bunch of things we could add to this. Like if you want to have MailChimp integration, enter your API and your list ID here, and we'll automatically build it so you can accept users in your mailing list. You want to integrate with outbound email, put your information there. And if you want to integrate with real-time error tracking, do that. Okay, so we now have this Wintellect demo thing. And here is all of our web stuff. So let's add this to PyCharm, open this in PyCharm rather. Oh, now one thing I do want to do here really quick, when we get to these more rich applications, you'll see that there's a lot of dependencies that this has. So if I look at here, you can see there's all these libraries up across the top saying you need some libraries for this to work. And in fact, here's probably where they most are. You need all these libraries because we're going to be using like an ORM and the error management and stuff. So you would like to be able to manage these separately from your main environment, right? Like in .NET, you have the global assembly cache, and you can install multiple versions of an assembly, but you don't have like complete control over that until you get to .NET Core, where you can do like bin deployable types of runtimes. So in Python, we can make this equivalent runtime here. I can say, let's do this. I can say Python 3, that is not a 3, -m venv. So I want to run the venv module in Python, right? Let me make sure I'm in the right place. I don't think I am. Let's go to Wintellect demo. And just on Mac, if you're using PyCharm, throw in a -- copies, or it doesn't work right. And then I give it a name. I'll say .env so it doesn't appear in the folder. It's just like this hidden runtime that we'll have. Okay. And let me activate that really quick so I can copy something I need to set up PyCharm. Doop, stop. So notice it's changed this to be the active executing environment. So let's go over here and say I want to set the interpreter for this thing. It's not to be the main one, because if I install all the stuff I'll need, it's going to affect that. But rather I want this one. Okay. All right, so now what we'll be able to do is I need to install all of these in here. Now I could just click this button in PyCharm, but let me just show you down here. Notice this environment has gotten activated. I could ask the same question. And it shows me this, right? On Windows, it's where, not which. And it's also, you just do .env/scripts/activate.bat, okay? All right. So I need to install those things, and just like you guys have NuGet, we have PyPI, so I can do that in a couple of ways. I could click this button, I could run the setup file, but there's already this requirements file. So let me say I'm going to install that. So I'll say pip run the requirement install run the requirements file like that. So that's going to go up there and download all the dependencies and install them, and this is going to take a moment. So it's a good time to see if there's any questions. Yes, somebody said Visual Studio 2017 introduced this, where this is cookie cutter for other things, right? So Visual Studio 2017 does have this. Somebody said they lost a voice. Everyone else, you guys okay? Can you hear me? Someone throw something in there. All right, great. Thanks. Sorry that you lost my voice there, but there, Maxim. Hopefully it's back. Okay, so notice these are set up, and there's one final thing. Give it a second. See this little indexing? It's like analyzing, basically creating the IntelliSense for us. All right, so all those went away. The other thing I need to do is I need to run this setup file and say register this thing in that runtime as well. Okay, so now I should be able to just click this and I'll have an app, assuming I got everything right. Ta-da! Okay, so we got this little app running, and we can open it up and we can go do some interesting stuff. All right, so here is our app. This came from that scaffold. It has these It's like a little banned e-commerce site that you guys can play with. Notice I put like a bunch of stuff. The Wintellect demo down at the bottom, like our little email is like our email address that we told it and whatnot. It has a CMS page, like a built-in CMS, and so on. So what I want to do is take you on a tour of what's happening inside this application, so you can see, well, what does the ASP.NET equivalent look like? What would it look like to do a web API? What does SQL, what does any framework look like in this world? Okay, I feel like if you come from the .NET space and you're like, oh, I see there's a really cool Entity Framework equivalent. I see there's a cool ASP.NET equivalent. There's a cool Web API equivalent. There's a cool Link equivalent. There's a cool Lambda expression equivalent. Like all the things that you love. You're like, oh, wait, this language has all of those? Well, that's pretty cool. I might be able to live here for a while or do interesting stuff here. So that's kind of the goal of the next couple of minutes, okay? So let's look around here at the things we got. It's all red because it's not committed to GitHub, which is kind of a little bit annoying. Let me go in here and, wow, we have a lot of files in here, don't we? I'll deal with that later. That might be too many. Not sure why we have that many files. So in here is really where our web app lives. And we have things that should look familiar. We have templates. They don't call them views, they call them templates. And we have templated pieces. Okay, so like that home page you saw looked like this. And it has a shared layout file. If you look at the shared layout file, it has all the standard CSHTML stuff, and then in the middle somewhere here, like when you create new templates, you just basically define what goes in that slot, very much like Razor pages. Okay, so like for example on this About page, like this is what goes into the About page. Okay, just that. All right, you pass in values, like these are properties on a class effectively. Here, and if you want to just print them out, you can do this. Let me find a conditional stuff. Let's go find the albums. They have some interesting things. Where are you, albums? Oh, there's no albums here. Is there anything happening that's interesting? Not really. Here, maybe, no. So you can do things like this. I can come down here and have a div. And in here I could have, let's do like just something really simple here. So I could have just an unordered list, and you can do cool stuff like this. Like if I wanted an unordered list that contained list items and I wanted 5 of them, I could say ul angle bracket li times 5 and hit tab, and I have a whole bunch of them here, right? But if I wanted to dynamically do this, I could come over here and say tal : repeat, and maybe I have a list of names. I could say name in names, and then I could just print out the name like that. Okay, so you have like a really nice, clean syntax, and it's a little different than Razor if you're coming from MVC in .NET. But this, I think in the end, is a cleaner language. Okay, so we have these templates. We have this concept of controllers. Let's look here. This is probably one that's sort of most full stacky. So we define a class, and it derives from a base class that we have that has a bunch of cool functionality, like what users logged in, save that in a cookie if they authenticate, and then they'll come back, and a bunch of stuff like that. And then we come over here and we say, here's an action, and it uses this template. Okay. We're going to come down here and go to the URL where this is. I'll show you what this is. It's in this page, and notice how it has a landing page, a dynamic page, and so on. So if I come over here, maybe I can show you the database. Let me try. So we're using what's called SQLite, and SQLite create this little local file. It's actually quite capable. Yeah, so I need to do some configure on that and download the driver really quick. It's pretty fast, so give it just a second. Okay, that's all good. Refresh. Here we go. So notice we've got our account page and our CMS page, and we can come here and modify the table, I think is what I want. No, open table is what I want. Actually, let me do the console. I could say open table is pretty straightforward what that is. But I can come here and say select star from, spelling is hard, from, and notice it gives you super nice intelligence. I could say like where, you know, these are all the things, right? There's no where clause here that I'm going to use, but I could. So notice it has the URL, a landing page, a dynamic CMS page, etc. And you just put whatever you want here, right? So then I can go to that page and it'll use the template and put that content in there in addition to all the other sort of data-driven pages. Okay, so with that context, let's look back at this. So it comes in, it makes this request, it uses the URL to say, well, what page are you think lives here? I mean, it's not a real page, but we're gonna go find it. And then we're gonna go to this thing I have called the CMS service, and it's gonna get the page, and it says if it doesn't find one, return a 404. If the page is a redirect, redirect them where the page says to go. So page.redirect URL. Otherwise, send back a model, which is really just a dictionary that has a thing called HTML that has the value of whatever the HTML of the page is. Okay. All right, so let's go down here and look. So this is like the ASP.NET equivalent of what you might have there, right? Let's go down into this. This would be the entity framework side of things, okay? So in entity framework, you have the object context, I think. It's been a while since I've done it. But you create one of those contexts, and then you can do queries against its properties using LINQ, right? This is basically the same thing. This is called SQL Alchemy. And let me show you how to find classes in here. So here's the CMS page, and it says we're going to have a URL, it's going to be a string, and it's going to be the primary key, which means it's got a uniqueness constraint, it's primary key, it's indexed, etc. Here's the created date, if we care, and notice we can set a function now as the default, and it'll execute that function. Unlike C#, it's not a property, it's a function you have to call like that. So you pass the function itself, and then SQL Alchemy calls it. And we have these other things. You could say like, maybe I want to index this, so I could say index equals true, things like that, okay? So you define these classes, and then when it runs, these databases, like here, this is automatically created. Notice here's the index, the auto-incrementing index, the primary key, and so on. Let's see, does this one have more interesting stuff? Yeah, so we have an index, like a uniqueness constraint and an index on the email, for example. So if you want to log in by email, all right? So we're going to take this and we'll define the various ones that are doing whatever in our, represent our model. And then I'll come down here, whoops, no, sorry. And you can say, I'd like to create a query based on this. And you can say, I'd like this, filter where the URL is this. I could do dot order by CMS page dot created dot descending, so we would get the latest, things like that. Okay. Now, because there's no semicolon, you have to, if you're going to cross these lines, one of the things you have to do is say, I'm continuing across this line. So that's what those backslashes are for. Now, because this is a single thing, it's a unique, and there's a uniqueness constraint. This order by doesn't mean anything, but you can see that it would. And let me do this for a second. Let's rewrite this as a query, and then we'll say page equals query dot first. And I just want to set a breakpoint right here for you. Okay, so let's go and run this in the debugger. Now notice we're stopped here. There's a bunch of really cool stuff to see in just a moment. Okay, so check this out. You can see if I hover over the URL, it'll say landing pages, a dynamic CMS page. But notice if I don't even do that, look what PyCharm has put in green next to there. Landing pages. And we have a session at some memory address. But check this out. Select star from CMS page.url. Where, from CMS page, where CMS page URL, right? So it automatically converts that to the actual underlying SQL code that it's going to execute. And then, of course, if I pull up my debugger, which is hiding, and I do a step, you can see the page is actually one of these pages, which you can bet has whatever HTML it has, right? This is a CMS page. Okay. So I know that's a whirlwind tour type of thing. Stop them all. I know it's a pretty fast tour of everything, but at the same time, I feel like it gives you a pretty good sense of what programming this looks like, right? If I want to create a new page, for example, I allocate one, I set its properties, and I add it to the session, and I call commit. That should look pretty familiar to you guys, right? quite nice. The query syntax is slightly different, and so on. Let's do one final thing before I just stop for questions because we're almost out of time. Let me clean all that up. So let's go over here and let's add an API controller. And I'm going to do that by copying this one real quick. API, because just for time's sake. So the API, what is up here? Stuff up I need apparently. Not that. And instead of doing one of these renders, saying here we're going to give it HTML, I'm going to say this is just going to return JSON. And I'm going to create a list, so I'll give it a list. Data equals, let's do this. And I'll give it two things. Let's say ID, sorry, I don't want to say it like that. I want a dictionary. I could use objects, but just for the sake of time, I'm going to use a dictionary. One, name, oops. Name is first thing. Second, third, fourth. And these better match something like that, right? And let's return data here. Okay, so instead of being page, let's call this a list. So I need to go and add this thing, basically register it in the routing. Now, unlike MVC, this doesn't have 100% convention. You have to say, here's one of the controllers, and then after that, like it'll find all the functions, but it's not bad. So API, I'm going to import that as API, and then there's a function down here. I got to call to set this up. So config API dot API controller, and let's just call it API. So we'll say /API/list, I guess I called it. Let's run this, see what we get. If I come over here and I click on the right thing, I say /API/list, boom, just like that, right? So very much like MVC, you want to return some JSON, you can create an API controller, and you can add all sorts of things like pretty printing, you can add content negotiation, et cetera, et cetera, et cetera. Post only, get only, so you could do like full RESTful stuff, but you can't do full RESTful stuff in 2 minutes. But this you can do in 2 minutes. One final thing. So over here in our site, I'm sure it's like basically impossible for you to tell across GoToMeeting or GoToWebinar, but this is super zippy. So for example, if I pull up the network tooling and I say show me only documents and I click here, see 15 milliseconds. If I go and click on the CMS page, it took 49 milliseconds, which is actually slower than I would expect. 32, it's probably the screen sharing that kills it. Okay, 30 milliseconds, but still 30 milliseconds is pretty fast. However, check this out. Like, if you might wonder why does it take 30 milliseconds? In the development only version, we have this little toolbar thing here. So if I click that, here's all the requests I've made. Like, so the home page took 7 milliseconds. And you can see the headers, you can see the performance. Watch if I go here. It even shows me the SQL query that was run, how many times it was run, how long the SQL query took, and so on. Isn't that cool? And if it crashed, it would have the error trace back, which is stack trace for you guys. And it gives you the performance. Check this out. So I went over here and I had to manually turn this on. But if I go back to history, to this, and I go to performance, I can see by cumulative time, like if I look for controller, you can see this controller page function took 2.7 milliseconds to run. That's pretty cool, right? There's actually some error handling stuff that's running on the outside of this that makes it actually look like it's slower. So for example, if I go over here and I turn this off, it's probably faster. If I do some refreshes and I pull that back up. Yeah, there you go. It was actually the performance stuff making it slow in Chrome. So 4 milliseconds, which this is pretty awesome. We're going to the database, round tripping it through a Chameleon page template, done in 4 milliseconds. Do you know how long this takes in standard ASP.NET MVC? Longer than 4 milliseconds. It's like 10-ish. Remember, the screen sharing is like killing my computer. So, you got to factor that in, right? It would be faster probably. So this is pretty cool. This is all fun. Okay, so I think I'm going to leave it here. if you're interested in working in Python, there are so many analogous things to what you want to work with. It has Lambda expressions. It has for each equivalent loops, just called for loops. It has Entity Framework. It has really nice web APIs. This is not the only choice, obviously. You could do Flask, you could do Django or whatever, right? But here's a pretty nice framework for creating RESTful services, right? If I really wanted, I could say the request method has to be get, and I could do something else for post, for example, like create one and add it to this list. I'm not going to do that because we're out of time. But it's a wonderful world. There's a lot of analogies and a lot of it takes a while to get into, but there's a lot of familiarity and friendly things for .NET developers in Python. So I encourage you to check it out. I will check in this code to the location GitHub/Wintellect. There it was. It went away. There. So here's the URL. I'll put that into chat for you. You can get this. That's not chat. That's questions. I'll put them in. There you go. So you guys can grab that, and I'll merge that in. I'll do a PR and merge that in shortly. All right. So let me look and see what the questions are. Exception handling. Michael, Andrew, you asked about exception handling. Is that like if there's an error in the website? I'm guessing, right? Like if, for example, for some reason this thing tries to access the database and it dies, you can do all sorts of stuff in there. In this one, I believe it has this sort of filter type thing going on here. Where is that? There. Somewhere. Maybe not in this one, but you can set up a filter type system to capture it. You can set up just an error page. Already we have rollbar integrated, which will report errors to us. But that doesn't help the user, right? It gives you basically the stack trace and all the details about the request. Okay. What about unit testing? Oh yeah, sorry. You're asking about try-catch. Yeah, sure. Well, that's no problem, right? So for try-catch, we absolutely have try-catch, just like you guys do. But they don't use the word catch. They say accept. Return response. Import this name from there. Say 400. That broke, or whatever, right? So if I go over here and I say raise exception, boo, I could even put a little message here, like so. Now, this is catching all exceptions, like a bear catch, but you could say exception as X, and then come down here. You get it to stop helping too much. Give it the X. Okay. So now if I rerun this, oh yeah, give it a sec. Tell it to run only one of them. Pull this up, go to /API/list. Boom. What did I put? Oh, I'm not sure what I did. Return response. Oh, I see. Let's put 500. Yeah, I guess 400s don't take. Yeah, it's like, you can't give it a message, which is fine. Or, wait a minute. Yeah, no, I'm pretty sure it's just saying like you can only return 500s. Let's see. Yeah, I don't know. I got to figure out what's going on with this. But yeah, you just try accept, right? And then you can have multiple accept clauses and so on. There we go. Now my demo works again. Okay, let's see other questions. Jim, you said very good introduction. Thank you so much. Is this my last? Is the last Wintellect Python presentation available somewhere for download? I don't know where it was. It was supposed to be sent out to you guys. Let's see, hold on 1 second. Kim or Rachel, if you're on the line, can you just drop something into chat, like a link from the previous presentation? Maxim, great presentation, thank you. Oh, Ronald says I have the parameters wrong. Yeah, I probably do, don't I, here? That broke. Yeah, I'm sure you're right, Ronald, thank you. I'll a lot of times just use name parameters, so I don't have to worry about that, but okay, let's try again. And yeah, well, that doesn't prove anything. raise exception. Boo. Yeah, there you go. Exception boo. Thank you, Ronald. That's awesome. I did have the parameter orders wrong. All right. I'm going to put it out to you guys. I'll answer questions for like 10 minutes or so. The webcast is sort of over time by a few minutes, but if you have any more questions, just throw them into the Q&A there, and I'll try to take them. And Kimberly says she'll send out both recordings to this group, so that's cool. So I did a previous one that was more on Pythonic code, less on like framework pieces. Michael, you're welcome. And Yana, or Jaya, sorry if I'm messing up your name, but you're very much welcome. Thank you for coming. All right, so probably the most important thing is you guys can go and grab this this URL, which I threw into the chat already, and you can star that or watch it or whatever, and pretty soon, it won't be immediate, it'll be a few hours, and then the materials will be there. All right, thank you everyone for coming. It was great to share all this stuff with you.